Assalamualaikum warahmatullahi ta'ala wabarakatuh. So today we continue our lesson. It's all about the X-ray. Okay, so before we continue, we need to understand the circuit here. And here is the filament, and the filament is connected to the power supply here. And then the filament also connected to the negative power supply. For this power supply, that means the cathode is your negative terminal, and then the anode, here is the anode, and then anode is connected to the positive power supply. So that means the anode is a high potential, because anode is a positive potential. Positive potential is a high potential, negative is the lower potential. And then here is the tungsten. Tungsten is the target. So tungsten is placed at the anode as a target. And then here is the glass tube. That means it's a vacuum. Okay. And then here is the voltmeter to get the reading, the potential difference between the cathode and anode. So it's a voltmeter. So in this case, so we continue. The diagram show a production of the X-ray. Okay, so this circuit is we need to use in order to understand the production of the X-ray. Okay, so we go for the process. Filament is heated by the current flowing through it. So here is the filament, and then it's heated by the current flow through the filament. So, and then what happened? The thermo-ionic emission occurred. So the thermo-ionic emission occurred. So when we heated the filament, so the electron jump out from the filament. So they put here, and then they produce the electron cloud. So they produce the electron clouds here, and then electrons are emitted from the filament. So electrons are emitted, they jump out from the filament, so to create the electron cloud. Okay, so we continue. Electrons are attracted to the anode by the high potential difference 10 power of 6 until 10 power of 7 volts across anode then cathode. Electron is negatively charged, so it will attracted to the anode. So here is the electron. So electron is negatively charged, and then they will attracted to the anode, because anode is a positively terminal. So we have the attractive force. So the electron will accelerate to the anode and hit the tungsten. Tungsten is a target, so hit by the accelerated electron. Okay, so we continue. From conservation of energy, electrical potential energy is equal to the kinetic energy. So we have the electrical potential energy is QV. Potential difference between cathode and anode is a V. Q is the charge of the electron, and then the change to the kinetic energy. So here is the kinetic energy of electron. So we have the changing in the energy from the electrical potential energy change to the kinetic energy of the electron. So the electron moving from the cathode to the anode and hit the tungsten. So during the process, the energy change from the electrical potential energy to the kinetic energy. So we continue. Then the electron hit the target. So the electron accelerate to the tungsten to the anode and then they hit the target. In this case, target is a tungsten. Then the electron hit the target tungsten and decelerate rapidly. So when the electron hit the tungsten or the target, so what happened to the electron? They start to decelerate. They're reducing the velocity. Then what happened? Kinetic energy of electron is converted to the heat energy. So that means the loss of kinetic energy is converted, the change to the heat energy. That means in this case, 99% of the kinetic energy of electron is changed to the heat energy, and only 1% is converted to the X-ray in terms of the spectra in this case. So the kinetic energy of electron, so the heat the tungsten, so that means the loss of the kinetic energy of electron is converted to the heat energy. So 99% as a heat energy and only 1% to produce the X-ray. Okay, so we continue for the number 6. There are two types of X-ray spectra. So now you know they produce you the X-ray. So I just explain here. So when the electron hit the tungsten, in this tungsten as a target, so they produce the X-ray. So X-ray, and then two types of X-ray spectra is a continuous spectrum and then the line spectrum. So there are two characteristics of the target metal. Okay, so in this case, this one we focus on the target metal. So we have two characteristics of target metal. So the first one is high melting point. Why we use the tungsten? Because we have tungsten is high melting point, not easy to melt. And then the number 2, the characteristic of the target metal is a heavy metal. Heavy metal, that means it has more in number of atoms. That means the metal has a lot of atoms. Okay. So before I continue, just to remind, there are two types of the X-ray spectra. So the first one is the continuous spectrum and then the line spectrum. Okay, so we continue. Okay, so we go for the X-ray spectrum. So in this case, I just X-ray spectrum and then I explain the spectrum here. Okay, so here is the continuous spectrum, and then we have the K beta, K alpha, L beta and alpha, and then here. So K beta, K alpha, L beta, L alpha is the line spectrum. So actually is what we can saw here is a peak. So here is the continuous spectrum and here is the line spectrum. So X-ray, in X-ray we have two types of spectrum, the continuous spectrum, the line spectrum. Okay, so we continue. So what is the continuous spectrum? So intensity varies smoothly with wavelength. So the intensity reaches a maximum value of the wavelength, increases and then fall as the wavelength increases further. So intensity varies with the wavelength. So here is the continuous spectrum, because the intensity is varies with the wavelength. And then when the wavelength go further, so what happened to the intensity of the continuous spectrum? It start to falls. So see the continuous spectrum is here. Start to fall when the wavelength is increasing. Okay, so we continue. How it can be produced. So now we need to understand how we can produce the continuous spectrum of the X-ray. An incident electron, so that's mean from the filament, with kinetic energy, they collide with the target atom. In this case, it's a tungsten. And then the fast moving electron interact with the nucleus of target atom as the electron approach the nucleus. Then what happened to the electron? The electron slowing down and lost its kinetic energy, where it changes to the X-ray in type of the photon. So the closer an electron approach the nucleus, the higher of the energy of the released photon. Okay, so this means this one is how we can explain how the continuous spectrum is formed. So we continue. So the scattered electron which now has energy less than the kinetic energy initial may have subsequent collision with another target atom, so generating a second X-ray photon. So the electron scattering process continues until the electron is approximately stationary and loses all its energy. We continue. All the X-ray photon generated from this collision between electrons and target atoms form the continuous spectrum of X-ray. Okay, so I explain by using this simple animation. Okay, so incident electron, so from the filament, so assume this one is an electron, then the electron from the filament they go and then hit the target atom. This one is the atom of the tungsten, because in this case tungsten is our target atom. And then when the hit, so they approach to the nucleus, and then what happened? So the kinetic energy of electron, so the velocity of the electron is slowing down, and then they lost the kinetic energy of electron as a photon. This one is a S-ray until the electron stop or lost 100% of the kinetic energy. So I explain. So the electron from the filament, so the hit the target atom. So then what happened? The velocity of the electron is slowing down. That means the electron is lost the kinetic energy. So the loss of kinetic energy, so as a energy of photon, that means your X-ray. Okay, so incident electron from filament, they collide with the target atoms. So loss of kinetic energy change to the X-ray energy or photon energy, and then what happened? The collision with another target atom. So this electron they collide with another atom and lost kinetic energy, change to the X-ray photon energy, and then this process still continue until the electron is fully stopped or lost all its kinetic energy. So this one explain how we can produce the continuous spectrum. For that, Thank you.